So hello everybody and welcome to my first engineering project, and in this series I'll basically just be going over and keeping track of all of my engineering projects. So this first project, it is a humidity and temperature sensor, and basically what it does is it just takes it with this DHT11 sensor, which I do have a video on, and then it outputs the humidity and temperature into the LCD module like so. And in this video, basically, I'll just be going over all the components I used to create this project, all the CADing I used, and just how it works in general. So the first thing I want to go over is I want to go over all of the components in it. So as you can see, first we have the basic stuff. We have our USB cord for the Arduino, our Arduino Uno, and then we have our LCD module, our DHT11 sensor, and then we have 7 hole-to-hole wires. And I apologize if the wiring looks confusing. I still don't have any pin to hole wires, so I was just connecting hole to hole and pin to pin wires together. And then we have our breadboard, so Arduino breadboard, USB, LCD module, our DHT11 sensor, 7 hole to hole wires, 9 pin to pin wires. And then also, you aren't able to see, but we have, because of this 3D modeled custom body for the application, there is also under this LCD module right here, there's a adapter which I soldered on. And if anyone was curious, so basically you would stick it through, there's a bunch of holes here, and then the adapter has these pins right here, and then you place the adapter, stick it, and then you solder. And this, all the links to these components are in the description, and I will shortly have a video of how to use this LCD module with the adapter in my Arduino Uno component review series. But anyway, with that, that's about it for components. So now we can get into the next section. Okay, so now I'll be getting into the wiring briefly. So you could do this really any way you want, using any analog pins you want, but this is the specific wiring I use to match with the code that I'll later show. So anyway, first we have our ground pin right here hooked up to this wire, hooked up to the negative side of this, and then our 5V hooked up to this right side. And basically the main idea is, so first let's go over this. So we have this 5V pin. This connects to the 5V for the DHT11 sensor. And this black pin under here connects to the negative pin for the DHT11 sensor. And then this purple pin for the DHT11 sensor right here. This connects all the way over to the A0 pin on this orange side right here. And I apologize if it's confusing. So negative pin for DHT11, positive for DHT11, and remember, positive is on the left side, negative is on the right side, and then the middle pin is a analog output for A0. And now from the adapter, so I'll pull out. So notice how we have 4 pins. So there's only 4 pins required for this LCD module. And so let's say it's connected like this. So this first pin is the purple pin, and this purple pin, this first pin is the purple pin right here. And I don't know if you could see, but this says ground. So this is purple. So this purple pin right here, this purple wire right here, just connect to the ground pin. And then the next wire is VCC. The next section is VCC. And this VCC is connected to just the red positive side of the 5V right here. And this is connected right here. And it's hard to see, but eventually it goes around, meets this white wire, and then this white wire goes into here. But just know, so this is the purple wire, and this is ground. This is VCC, this is 5V. Then this next one, this pin right here is the white wire. This pin right here, the third for the SDA pin, that is the blue wire. And that blue wire connects up all the way to here and goes all the way to A4. So SDA is this blue wire right here, and it goes to A4, and that's this one right here, and then it connects all the way down to here. And then the last wire is the black wire, and that is the SCL pin, and that pin hooks up to A5. And you can use any analog pin you want but this is just what I use for my specific code, and this will be brought up later when I go over my code on the Arduino IDE. But then anyway, that's about it for the wires. And I know it looks complicated maybe, but it's actually not that complicated, I promise. It's just there's so many wires everywhere. It just looks like super unorganized. So anyway, that's about it for wiring. So now we can get into the CAD of this. Okay, but now before we get into the CAD of this, first I just want to go over the 3D modeling and all the models that I'm using in this building. So basically, if we pull this up, so we have our main body right here, right? And we have all this, right? And then we also have our sensor cover right here. This is a another individual piece, and I used a little bit of hot glue to glue this on over the sensor. So it creates that like pretty more clean effect, and this went between here. And basically so now also I did use hot glue for this section, and then I used some more glue for this to glue this part on. And now in a second I could show you how I 3D modeled this. So now let's go over the models. Okay, so you can see here we have our main body, and then we have our sensor cover, and then our final assembly. So I'll be going over the main body first. And for anybody curious, I use the CAD platform Onshape. But anyway, let's get into it. So first we have our 3D model, and so basically the way I approached this is I knew that I had to dimension the sensor and the LCD module first. And then when I did this, I basically just measured it with a ruler, right? And then I wrote down everything. And then I began to dimension everything and plan out a design. So of course we have our sensor area. So this is where I glued the sensor in. And then I just stuck the wires out this close end right here. And then we have our LCD module, which faces this way. And then the adapters under it, the wires will come through this section right here. And basically just come out this area. And then after that, we have our LCD place right here. And I just dimensioned the LCD and then glued that in right here, and made sure that the adapter's wires would still be able to come out this hole. And then from there, that's about it for this model. And I might in the future make a CAD series. So if you're interested in CADing, you'll be able to do that. But I would recommend that you get a 3D printer or something, or have access to a 3D printer, because it's not too helpful if you just know to CAD, but then you don't have a 3D printer around you to print your designs. But anyway, so now we have our sensor cover. So this is just a super small block, and this goes right here, and you'll see that in the assembly. But basically I just used this because I thought it would look more clean if I had a more like flush box without any extra holes in it from that sensor. And you'll be able to see this in a second, and I did show this beforehand, but now we can get into the assembly. So I did a rough assembly of what the final product would look like. And so basically if we go down here, we could see how, so we have our LCD right here, and then we have our sensor cover, and then the sensor cover basically just goes like around here, and it covers that extra open area for the sensor between the actual sensor and the wires that connect to it, and it just makes it look more clean. And then I printed these separately, and this the bigger the actual base took around 2 to 3 hours, and then this sensor took like, or this sensor cover just took like a minute or 5 minutes or something. But anyway, then after that I just assembled these together with some glue, some hot glue and Gorilla Glue, and then besides that, that's about it for the CAD. Okay, so now lastly we'll be going over the code. So first we're including this basic dewire.h library, and then as well as the liquid crystal I2C library and the DHT library right here. And I'll be creating a folder in the description for the libraries that you have to install for this project. But anyway, now, so first we define A0 for our DHT pin, and then initialize DHT by using this code from the library. And then now down here we initialize our LCD module, and if you get the same as me, which in the link for all of the components are in the description, but if you get the same LCD and LCD adapter as me, then you could set all these to the same stuff. And then this is initializing LCD, this is initializing it, and then this delays it to let the system for the LCD boot up. Then this sets the LCD cursor to 0, and this is what makes it say project 1 at the start. And then it says LCD 01, so this makes it go to column 0, row 1 for the cursor, so like where it types stuff. So that's what makes it appear project 1 on the top line, then weather station on the bottom line. And then we have delay 4000 because we're waiting for a bit until we access the sensor. And you don't really need to do this, but I wanted to make this message display for a bit. And now down here we have just the reading data from the DHT11 sensor. So all we do is DHT.read11. This just specifies it's an 11. And then it reads the analog 0 pin, which we defined up here. And then from here, it just displays data to the LCD. So first we run the clear method that comes with the LCD library. And then on the column 0, row 0, it displays humidity, colon. And then since you can't type a variable like this onto the same line, we have to do this, humidity, and then LCD print, and then print it again to show the humidity percentage. And then we go to column 0, row 1, so it goes from, like, for example, the first line to the second line, and it's 0 indexed, but just imagine it's first to second, and then it says temp, and then colon, and then same deal where we have to just print this, and then this again, and then it displays then it waits 5 seconds, because you don't want to read in the sensor too much, because it could heat up and break, or be messed up if you try to read it too much. So that's why we have a 5-second delay. So anyway, that's about it for the code. And now, for example, if for the libraries, I could show, so you go to Sketch, include libraries, and then I could show down here. So we have Liquid Crystal I2C and DHT. These are the 2 libraries I used, and you'll just want to go to Sketch, include library, and then add those 2 zip libraries that I provide in the description, and then click these 2 buttons to add them to your code if you're interested in using any of these components. But so anyway, that's about it for the code. So yeah.